So all forces, when we describe them, are going to have both a size and a direction. So we will use the units of newtons, which will help describe the size, and then we'll say whatever direction the object is moving. So for example, something could have a force of 5 newtons to the right, something along those lines. A force cannot just be brought out of thin air. Something is not going to move without a force being put on it. So in order for any push or push to occur, something has to receive a push. That seems pretty simple. That seems pretty obvious. A box cannot be pushed or cannot move unless something is pushing on it. Same for something that's being pulled. But sometimes it's kind of hard to tell what's exerting the force itself. So what is delivering that push? What is delivering that pull? And that's something we're going to get into here. So one part of force is something called net force. So this is the resultant force that you get when you combine all the forces exerted on an object. So most objects do not just have one force being put on it at all times. Let's say you are pushing a box across the floor. You are putting a force on that box by pushing it. There is also the force of gravity on that box. That's a whole nother force. There's also the force of friction that's resisting your push. So there's right there, that's 3 pushes alone, or 3 different forces alone that are on that box itself. So when we find net force, we are finding the total force in which direction that object will be moving in based on the forces that are on that object. So it's going to determine which direction the object moves and with what force it moves. So we're going to learn how to calculate that right now. So this is kind of similar to resultant velocity. Again, this is something you can write on your formula sheet, but it's pretty similar to resultant velocity because we're adding things together when they're in the same direction, and we are subtracting the forces when they're in different directions. So starting with the same direction, if you have an object, right here it's just represented with a rectangle. If you have an object that has something with a 5 Newton force that's pushing it to the right, so in this case, I've got, sorry, I'm trying to find my pen. We've got the 5 Newton force pushing to the right. So it's pushing on this box, let's say, to the right. We also have a 7 Newton force on the other side that's pulling it to the right. So they're being pushed and pulled in the same direction, but there's just 2 different forces. This would be like if you had one person trying to push a heavy object on one side while the other person is trying to help them by pulling it on the other. So you add them together because they're in the same direction. So 5 plus 7 gives you 12 newtons to the right. So you describe it with the size, which is 12 newtons, and you describe it with the direction, which is to the right. Just to make sure we know we are listening, go ahead and underline your name on the top of your paper so that I know you were paying attention to this video to get full credit, please. So, like I said, if you go in different directions, you are now going to subtract the forces. So, in this case, I showed you that we have 15 newtons of a force being pushed to the right. So that arrow is going to the right, 15 newtons to the right. On the other side of this object, we have a force of 10 newtons being pushed to the left. This would be like if you had 2 people on opposite sides of an object, and they're pushing towards each other. So one's pushing with a force of 15 newtons, one is pushing with a force of 10 newtons. So we take the smaller and subtract it from the bigger. So in this case, it's 15 minus 10. That gives us 5 newtons, and we know it's going to go to the right because that force is the one that is bigger. So that would be like if the person on that side is pushing with more force, it's going to move in the direction of the stronger force. It's the same concept with something like tug of war. If you have someone pulling with 15 newtons towards them, and then the person on the other side is pulling with 10 newtons towards their direction, the 15 Newton person is going to have a stronger force. So it's going to pull that rope towards them rather than the other way. Whichever's the stronger force, it's going to move in that direction. So with this, we have something called balanced and unbalanced forces. So if any time the net force is not 0, we call that unbalanced. So anything that is moving is automatically unbalanced, because we know if it's moving, there's definitely not a net force of 0, because something is pushing harder than the other forces around it in order for that object to move. So that means we have some kind of acceleration happening. Any object that is sitting still is called a balanced, has balanced forces, which means its net force is 0. If every force on that object is balanced out and it balances out to 0, that object's going to stay at rest. So anything that is not 0 is unbalanced, anything that is 0 is balanced.